Good morning, ladies and gentlemen. Thank you so much for joining us. It's my pleasure to welcome you back for another really fantastic discussion ahead. We've heard a lot about how nuclear energy is the lowest carbon source. It has the smallest environmental footprint. The economics are changing. We're seeing low cost, high performance, high quality nuclear energy being delivered already today. And global studies have underscored the very important role that nuclear energy will play in our climate challenge, not only in the electricity sector, but in our hardest to decarbonize sectors across industry, heat, and transport. Because of course, nuclear technologies not only make electricity, they also produce heat. Very, very valuable in our climate challenge. So how do we move nuclear to 4G and beyond? With us today is a very distinguished panel. I'm delighted to introduce you to Patrick Fragman, Westinghouse President and CEO. Good morning. Sama Bilbao-Leon, Director General of the World Nuclear Association. Philip Norrell, CEO of Orano. Petro Kotin, Energy-Atom President. And finally, Bogdan Stronek, Chief Nuclear Officer and member of the Board of Directors at CZ Group. Welcome to all of you. Now, I'd like to kick us off by firstly talking a bit about public acceptance. How do we really demonstrate that we can deliver? How do we demonstrate and reinforce the opportunities not only for our societies in big cities and so on, but also for remote communities? So I'd like to kick off by inviting Patrick to offer us some comments on that. Thank you.
Good morning, everyone. Good morning, Kirsty. This is one of the key topics which today is still hampering a bit the development of nuclear energy in many countries. And it boils down to two issues, in my view. The first one is the positioning of nuclear energy. For many years, nuclear energy has chosen the wrong enemy. We have to make sure that it becomes clearer and clearer that nuclear energy and renewables are best friends. And I'm dreaming of a joint congress in that forum where it would be both renewables and nuclear. And that would show a clear signals about this coupling. There is also a matter of the industry itself. There is a lot of communication, especially done by some, let's say, smaller developers, which tend to oppose one form of nuclear energy with another one, like larger reactors with smaller or old plants versus new ones. The reality is we will need everything. We will need Gen 3, we'll need Gen 4, we'll need smaller reactors, we'll need larger ones, and we'll need all of this because at the end of the day, it will simply not make the cut. In terms of the second topic is make things right, is we have a unique opportunity to make sure that when we do new build, we effectively make sure we apply the lessons learned, standardization. We have the economies of scale. We make sure the supply chains are well trained. This is the approach that we have, for instance, for the AP1000, where we have already 4 units in operations and 2 more being finalized. Where we are really applying the business models and the lessons learned that helped us to do things right in the next stage, which is opening now.
Fantastic, yes, and you're so right that support for nuclear and renewables dramatically increases when you present them as a combination rather than separately. So yes, what a fun idea to think about combining in a conference. Petro, may I invite you to comment on this also? Thank you.
Yeah, talking about public acceptance, I mean, this is the most important thing for world nuclear industry, and also this problem is we have met in Ukraine with our population in Ukraine. For me, it is 3 actually items to address, and first of all, that be a safe operation of nuclear in the country. And talking about our company, we have 15 units in operation, and all of them are of former Soviet Union design, and we introduced a lot of safety measures, safety upgrades, and the special program, which is complex safety upgrade program for the cost of about 1.2 billion euros. And now we are just finishing this program, so the safety is understood by the population, and we just bring our opinion on that to them. The second one should be, of course, reliability and low cost of operation of nuclear power plants, and so we can manage to have a low tariff for electricity for population in Ukraine. And so we also give them information that this is why they can pay less for electricity than, for example, if they buy the electricity from other sources which are available in Ukraine. And the third one is for public acceptance in Ukraine is just increase PR company in Energatom. And now we are working on taking the best professionals in this area and having additional information and more people, more staff allocated for dealing with public acceptance of nuclear. And I just give you one example. For example, we have a long forgotten site in Ukraine. It was called Chigirin nuclear power station, and in the time of the former Soviet Union, it was decided to build a nuclear power plant in there with 4 units of VVR 1000 design. At that time, the construction was started, and then Chernobyl catastrophe happened. And after that, it was moratorium introduced by the government on construction of new build in Ukraine. And still, there is ruins of that initial construction in there, and also the town of Orbita, it's called, and it's 9-story buildings there with open windows, empty windows in there, and also some administrative buildings and all these type of things, you know. And people just passing by and driving by and see all this mess. And now when we are renew our nuclear program in Ukraine, we are starting from actually poll of the people just to know their opinion on that. And we have like 65% of population in this area who support building the nuclear power plant in there. So we consider this like a new program, and we consider it like a perspective site to build in Ukraine. So these 3 actually contributors in public acceptance would help to develop nuclear in our country.
That's excellent. Thank you. Thank you very much. This is really an interesting bridge that we have to build from the past to the future. And you know, maybe Sama, you could build on the theme of the synergies between nuclear and renewables, because of course renewables, you know, in many people's minds do represent the future. But also talk a bit more about how we can raise awareness about the many benefits, the environmental benefits, the job creation, the socioeconomic benefits that nuclear technologies can bring.
Yes, thank you, Kirsty. No, I agree that, you know, we are seeing more and more recognition about the very important role that nuclear energy can play. And obviously, this is important. But I really think that we need to do still much more. So part of the reason that people are recognizing nuclear, of course, is the fact that some people are seeing how we cannot really reach 1.5 degrees only with some renewables. So we are going to need something more. So that's important, and that is a very good story that we have to build upon. But we really need to go a little bit beyond that. And you know, there are many good stories that we can tell about nuclear. And for example, you mentioned one. It's not only the fact that we can produce very clean, affordable energy, but it is the socio-economic benefits that come together with nuclear energy. It is the jobs, it is the economic trickle down throughout the entire local, national and regional economies. And it is also it's a very important catalyst for additional economic development in our country. And we have seen that in many countries around the world that have the initiation of nuclear energy truly catalyzed the industrial growth in the country. But you know, in addition to those stories that are very important, I really think that sometimes perhaps we need to talk maybe less about the technology itself, and maybe we can talk more about the human stories about the technology, because I think that sometimes that paints a better picture of what this technology is truly about. So it's not only about safety is not only about economic energy or low carbon electricity. It is also about the men and women that are behind the technology, the work that many of you are doing. And it's also about the life-changing benefits that this technology brings to all kinds of people around the world. I mean, to me, if we can paint this picture of a different world in which basically every human has access to abundant, affordable, clean energy 24/7, that is a world that is not the world that we live right now. Where people have access to fresh food, to fresh water, to health, to education. I mean, for example, when you paint the picture, which is very dear to my heart, of the opportunities that 24/7 energy affords for empowerment of women. So suddenly women around the world will not be limited to doing menial tasks. They would actually have power at night. I mean, they will be able to use devices that are going to make their lives easier. They are going to be able to study at night. They are going to be able to perhaps have jobs or occupations that are not only rewarding, but rewarded. They are remunerated, and they are going to contribute in all aspects of society. So I think that if we can paint those things, certainly brings additional dimensions to the many contributions that I think people are starting to already realize.
That's wonderful, Sama. That's exactly the kind of values alignment, really sort of leading with the motivation, the outcomes that we can deliver, that is so powerful, I think. Patrick, please.
Philip, I guess, but no problem. On your original question, and of course on the skills, as was mentioned, there are 1 million jobs linked with nuclear in Europe. That's quantitative, but there are human histories behind, as Sama mentions, and these are the competencies. And you mentioned here the complementarity with renewables, and I would go beyond. Electrification is the big stake to decarbonize, so multiplying electricity by a factor 2 at least over the next decades is a major challenge. And indeed, nuclear is affordable, safe, and available 24/7. But on top of that, if I take an example on Orano, we have built skills with the whole industry over 70 years for addressing mines. We are mining uranium around the world, and we are recycling materials, meaning we know how to extract metals from different things. And in our thinking, strategic thinkings, how can we help renewables? We have come back, for example, to the recycling of batteries. There will be a high number of batteries being recycled, and the technologies from nuclear can be useful there. And we are there as a nuclear company, no problem. But it's good that other companies don't push us away because we are a nuclear company. They see that we can bring things in this history. And same thing for nuclear medicine. Bringing nuclear to a country also helps to bring a culture of safety, radio protection, that can help also for nuclear medicine. And yesterday was a talk about Race for Hope. Bringing nuclear medicine in a vast number of countries that do not have it is quite useful. So yes, the nuclear industry is not only about energy, producing megawatt hours, but it can bring a number of things to globally our transition in the world.
Philippe, thank you. Bogdan, I'd like to come to you now, because for nuclear technology to really contribute within the timescales of climate change, at the scale for climate change, we do have to, move into that 4G. We have to evolve the delivery of the technology, which means changing the technology transfer, the regulatory landscape. Talk to us a bit about how we can address these challenges.
Yeah, we are living in pretty fast changing world, full of different challenges, but also on the other hand, full of opportunities. So I believe that we have to keep looking for new solutions for operations. We can start with current fleets, with a long-term operation, and how to ensure the safe operation for as long as possible. How to be as effective as possible, doing upgrades, doing fuel cycles optimization, and so on. We may focus on load follow operation and grid services support. We may focus on base load operation together with some potential of heat or hydrogen production or other energy storage tools. We have to foresee regulatory changes, not to be surprised, and if possible, to be a step ahead before any regulatory changes, because if we stay, then it's much more expensive, much more difficult to comply with all of these steps. And there are many other challenges, so let's keep ourselves at the state of the art, keep ourselves attractive enough for a new coming generation, because there is the world full of digitalization. We can move to paperless workflows. We have new inspection methods and new technical tools, so let's keep attractive.
Fantastic. So modernizing, standardizing. Patrick, may I ask you to build on this theme really for, it's going to be so necessary for global markets.
I mean, Westinghouse has a long-standing history in transferring technologies. We did it starting, for instance, in this country many decades ago at the birth of the French nuclear program, continued in Korea, in China, in Spain. At the end of the day, we maintain a very large network of contacts, relationships, and constant work with regulators around the world, not only on new build, but also on the installed base. Everything we do on fuel, on services, helps us to understand the requirements and the expectations, because we don't have a harmonized framework internationally. And at the end of the day, it's also going to be about technologies. I mean, Bogdan was highlighting it in his answer, is digitalization is going to help us also to do things differently. And it's a change not only driven by technology, but driven by generations. We have new people coming to our teams who have different ideas on how we have to manage information and knowledge and share it across, not only internally with the company, but also with suppliers externally. So this is part of what we bring to our customers. This is what we bring also to bring certainty in the delivery of our projects and our technologies to the market. And I believe this is today needed more than ever, because we indeed don't face harmonized requirements throughout the world. So when we have an approach to develop a technology, we usually have a global scale approach. The AP1000 is, for instance, licensed not only in Europe or in the US, but also in China. The microreactors we're developing will be licensed globally, and so on and so forth.
That's fantastic, yes. So I'd like to open up some new themes now around some of the crises, of course, that we've all been experiencing recently, with the energy crisis, the energy security, combined with the need to continue our decarbonization efforts, but also to maintain climate resilience, as we're already experiencing climate impacts in Europe, in the United States, but all over the world. So I'd like now to turn to, Patrick again, in fact. You're up again. To talk to us really about, the contribution that nuclear technologies can play in helping us to meet this intersection of challenges.
Without repeating what has been said, it's clear now that nuclear will be part of the solution. After that, there are two types of countries, the ones which have already said it and the ones who don't dare to say it yet. But this is, when you look at the math, it just doesn't tie in without the contribution of nuclear. And not only nuclear for electricity, there are district heating applications, there's applications in the area of hydrogen, because we talk a lot about decarbonizing power generation, but there is a big challenge on decarbonizing transportation. And this will go through electricity and hydrogen generation. And if you want to produce hydrogen baseload, green hydrogen, there is not too many ways to do that, except for the few countries which have very large hydro potential, and they can be counted in one hand. So at the end of the day, it's going to be about bringing those solutions to scale, but also adapting to the new energy grids. And the new energy grids are not only centralized grids, they're also decentralized grids. And we will need a combination of large reactors, but also decentralized generators and decentralized power generations, which is probably better suited to smaller type of reactors. So there is a vast amount of innovative solutions that the nuclear and industry in general can bring.
Yeah, and it's interesting to think that we can actually use the existing nuclear fleet really quite cost effectively for a much broader range of energy services, including hydrogen production. Sama, would you like to build on this? Thank you.
Yes, I mean, I think that Patrick painted a very good picture, but maybe let me add a few things. So I think that, first of all, when we are looking at countries that are trying to avoid these economic difficulties that we are seeing in some markets and this hardship. So I think that the first thing that it needs to be done, of course, is to put together an energy mix that is diverse and that is as much as possible reliant on what we call maybe homegrown type energy sources. And of course, in that sense, nuclear would be a very good one because, of course, part of the very good some of the very good news about nuclear is, of course, the fact that it's somewhat, it avoids all these interactions due to perhaps this geopolitics or maybe the fluctuations of some energy markets. Because if you think about this, if, for example, the price of uranium were to double, the impact on the price of electricity produced by nuclear would only be 10% or something like that. So clearly, that insulates nuclear from these fluctuations in the market. So that would be the first thing. The second thing that I think is very important is we do need to look at the entire system when we do long-term planning. We cannot look just about this plant here, that plant there, the other plant over there, because as we know, the old concept of the levelized cost of electricity per unit no longer applies because we have these energy systems where we have very high penetration in many cases of intermittent energy sources. So of course, there is all these added system costs, you know, like the balancing costs, like the transmission costs, like all the spinning reserves that need to exist in the grid, et cetera, et cetera. So it is important to look at the entire system as a whole and look at the price of the system as a whole and how to optimize the system as a whole. And then if I may say, the last thing that I would do in order to, that I think is important to avoid these price surprises, and I think is actually very, very, very needed, is we really need to take a step back in the design of energy markets. I think that many of you would agree with me that current energy markets are very dysfunctional. They really do not work for almost anybody. So perhaps it is a good time to take a step back and re-envision those markets. And this is going to become even more necessary because, as you know, in the near future, we are going to have, as Patrick said, centralized systems, decentralized systems, but we are going to also see the coupling of different energy systems, electricity, mobility, hydrogen, heat. So we really need to come up with different pricing and ways to value these systems so that not only everybody gets what it deserves price-wise, but also we have in the system built-in signals that are going to incentivize long-term planning and investment, not only on the energy generation, but the entire infrastructure. So those are some of the things that I would do to solve some of those problems.
You have a great list. This is, I can see lots of nodding. I don't know if anybody would like to just add any comments on market design, because this is an important detail. I can see Philippe.
No, I was nearly taking it personally because there's market design of electricity. But there is also market design for long-term assets in the fuel cycle to provide materials. As a runner, we have invested in conversion and enrichment for long-term, so we're ready. But if you think about a uranium mine, if one day, you say the price is high and you want to mine, and the price is low, you don't want to mine. So enhancing the price mechanisms and or appreciation by newcomers, by new customers, by customers from today is really important. Also typical for uranium mining, and I will come back to other aspects which are less linked with market pricing. But market pricing is key from electricity and for the supply chain.
Very good, thank you. Petro, would you like to build on the theme of the non-power applications, maybe the hydrogen production opportunity?
Thank you. In Ukraine, we have the situation when nuclear actually plays a very important role in overall energy mix in Ukraine. So we produce about 55% of electricity in Ukraine on our nuclear power plants. And this is almost like you do here in France, where this share is about 70% or something. But the difference between Ukraine and actually France is France has maneuverable capacity on nuclear power plants, so they can work in full load mode. And that is not the case in Ukraine, so our reactors are designed just to work on a base load and not in full load mode. So we have a problem in there just to maneuver the capacity, and we have like our goal just to operate our units on the baseline, and when we have situation when the system grids does not require our power, then we need just to decrease power, and that is not good for our unit. So we consider in this regard some other sources of electricity consumption, and we are looking forward just to create hydrogen production industry, just to power these facilities like electrolyzers during the time when electricity is not required by the system, but we still can produce it and then spend it on production of the hydrogen. There is a comprehensive program at the moment which is under consideration now on that. The problem also is that in Ukraine we do not have a lot of customers for this hydrogen. So to use hydrogen, you will need just to create the whole structure from the very beginning to the very end with consumption. So that is the problem. And another things which can be used is like reheating or heating, district heating, for example. But we do this already, and also maybe desalination of the water, but it's not the case for Ukraine as well. So that is.
Very good, thank you. Yes, and that's the interesting challenge with hydrogen as an end-use fuel. It would require a lot of investment in the new associated infrastructure for storage, transport, and end uses. So ideally, we would think about using hydrogen as an ingredient, potentially in drop-in fuels, like ammonia, for example. But for that to make sense, the hydrogen has to be very cheap. So we need a lot of innovation to drive down the cost, but nuclear technology is very well suited to producing cheap hydrogen. So let's look now at the global supply chain crisis and how that's impacted our sector. It's impacting all sectors in all kinds of interesting, surprising ways, but tell us a bit about the experience in the nuclear sector.
Frankly, globally speaking, the nuclear industry resisted really well the pandemic. Nuclear reactors around the world have been operating with a really high success factor. So, and we were providing, and it was also bringing meaning for the employees because we were supplying electricity for hospitals, for people at home, etc. So it was really a huge success for the nuclear industry. Sometimes, of course, it was less easy. Globally, as Orano, we always operated above 80% of our full capacity, but of course, in remote areas like in Canada, we had to close the mine for some time. But globally speaking, I mean, the nuclear supply chain resisted very well to what happened and put in place. I mean, we are used to operate 24/7, so somehow putting in place also sanitary measures was something that was, I mean, built in our operating procedures for all of us. Nevertheless, of course, this puts into light the importance of long-term assets. Of course, the nuclear reactors. I talked about the mines, enrichment, conversion, but also for countries joining nuclear, thinking about the nuclear spent fuel, which is in small quantities, but having already foreseen what happens in terms of crisis, if you have to store your fuel, if you have to discharge, if you have to transport, is key. And it reacted quite well. but nevertheless, it needs really training, because if you want to talk about, I mean, opposition is always talking about nuclear waste. Nuclear waste can be managed, it's small quantities, there have never been an accident, or except one in history on nuclear waste. You can recycle nuclear waste, and here in France, we do recycle it as other countries, but you can store it and store it directly. But all this needs to be taken into a culture in advance, a long discussion, as also was mentioned in Ukraine, for public acceptance. And then it can resist a really high number of disruption, as it has been shown in the last pandemic.
Thank you. Yes, absolutely. Bogdan, would you like to add to this issue of critical infrastructure? Thank you.
Well, thanks, Philip, to highlight that being a part of critical infrastructure, we did pretty well during the COVID pandemic. We have to be aware that there are significant market changes around the scale of suppliers, and their number is different. Usually it's coming down, so we have to react on. We have to look for stability, for reliability, and the quality of deliveries, because many of us faced with different quality issues. As supply chain changes, we may focus on, for example, commercial grade items, because if something is good for aircraft industry, why it's not good for nuclear industry? And very often, if we will buy a small part for euros, which is standard production for aircraft industry, and we buy the same part for nuclear with all of the nuclear certificates, we pay hundreds. So it's crazy business. So let's look at it at least in case of lower safety grades and non-safety grades items. From operator point of view, it's about looking of a balance between internal capabilities and external capabilities, the balance of insourcing and outsourcing, ability to be at least intelligent customer and know what to focus on and know what to keep in our hands, because we have to keep the vital activities. And for the future, definitely there is promising trend of decarbonization, and as Patrick and Petro highlighted, there's clear complementarity of nuclear with renewables and hydrogen production and heat production. There is sure SMR's potential, but not for this decade. It's for the coming decades, so let's be aware of it, because some politicians tend to focus on SMRs, waiting for them, but the result may be that there will be no nuclear facility operated in Europe within a couple of years. So we have to be aware of current steps, and we have to be aware of all of these potentials, but also challenges.
Very good. I'd like to double click for a moment on this issue of the nuclear premium that you raised, because actually it's very interesting to sort of think about innovation as an opportunity to design products that can reduce regulatory scope whilst maintaining the very high quality, the very high standards that we would expect to see, but enabling much more commercial, off-the-shelf balance of plant, for example. We're starting to see that a little bit more in the small modular reactor sector, but there's opportunities, I think, across the whole piece. Would anyone like to comment on that? Patrick, would you like to comment on these?
I'm not sure it came with the small modular reactors. I mean, from what I see, it's the commercial grade dedication is a program which is well established in the nuclear industry, which, at least from our perspective, we have started to put a focus on it, let's say, probably 15 years ago. And it's quite a successful program, because to Bogdan's point, indeed, there is a fair amount of additional requirement, documentary quality assurance in the nuclear industry, which at the end of the day is going to make a completely different picture in the acquisition cost for the end user, apart from the oil and gas, for instance, and apart from the nuclear industry. So we are trying to work on that, and that's a piece where we need also to bring in another stakeholder, which is the regulator, so that they can also have their voice on safety critical systems where obviously the requirements might be different. When you look at the economics of nuclear industry, I think I would paint two pictures. It's a tale of two stories. The first one is the installed fleet. To be fair, the track record is great in many countries where the nuclear electricity effectively is one of the lowest costs, as highlighted by Petro, but not only in Ukraine, in many other countries. And then for the new build, we have to apply the lessons and the lessons of what we did right, but also what we didn't do right. And at Westinghouse, we are well placed to know both. And I think we've drawn the lessons and we've taken that at heart to make sure that we make it right for the next time.
That's right. You have to invest in order to learn and build that skill and that capability. And then the important thing is to maintain it and apply it. So that's how you achieve the programmatic cost reduction. Oh.
And that's something which I think we don't stress enough as an industry is people tend to forget it's a knowledge business. When you don't build plants for 20 years or 30 years, there is a cost to it. I mean, just ask BMW to do one car every 30 years, and you would see that the cost of that car and the timeline of delivery would not be the one which is shown on the catalog. So I think this is something that we need to take into account, and from an industry perspective, have fleet strategies, standardization, make sure that we try to standardize and harmonize the requirements between different customers is part of making the benefit for everyone.
Yeah, I think that the mantra now that I'm hearing in the US is stop building airports and start building airplanes as well. So before I open it up to the rest of the panel, I'm hoping that some questions have been submitted. We have a very distinguished and wonderful panel here. So if there are questions, I'm not sure how this works, if anyone would like to display them. Otherwise, I'll just keep asking questions, which is also fine. So I'm not seeing any just yet. Please do feel free to submit some. So I'd like to just see, maybe Sama or Philippe, would you like to comment any further on this, the sort of modernization, the application of new automation and AI and the sort of really, let's bring the sort of 21st century technology into our sector and see how it can improve our productivity and delivery.
Well, I think, and Patrick started to talk about this. So I think that the nuclear industry historically has done a very good job incorporating continuous improvement, and we see this on the way our units have been working. So perhaps we have been less quick to incorporate these a little bit more disruptive technologies because we really needed to adapt our regulatory frameworks to these technologies. But I think that certainly, I talk quite closely, obviously, with industry and with regulators, and there is a lot of appetite to incorporate these new technologies because they really are going to make nuclear power plants much more cost effective. So, but not only for the new units, obviously we've talked about the small modular reactors, standardization, factory fabrication, use of artificial intelligence or these digital threads or advanced manufacturing. All those things will be quite useful for the new generation of reactors, large and small. But in reality, we are already incorporating many of these innovations in the operation of our current fleet of reactors. And we are making them more effective, more cost effective, and I'm sure that Bodam can also give examples on how we do that day after day.
So Philippe and then Bogdan, please.
Yeah, one thing we did not mention specifically to a fuel cycle is that we are now clearly selling uranium enriched above 5%, both for the existing fleet and for Gen 4, for delivery starting in 2 years for 6%, and then going up 7, 8, and up to a 20% in the years to come. So clearly there is also limits, disruptive limits, that can be our own limits, the limits that the industry or governments imposed and in the past, but can be changed, and even for the existing reactors, it can be a benefit to as long as one can cope with it. And then, of course, with modern technologies, we changed not in reactors, but in our fuel cycle operation, in recycling operations, we changed a major equipment. It took us quite a lot of time, 4 months, but when the engineers originally thought about it, they thought it would take 10 months, and it's 25 million euros per month. So we just, finance our whole digital transformation for next year and the year to come with that success, and mostly by reducing risk. It's not that we did the thing differently. It's we prepared so much with new technologies, by digital simulation, by training, by good visualization, but we took away the risk and we delivered on time, on schedule, and in fact 4 months instead of 10, which was quite a success. So yes, indeed, nuclear is at the limit of technology and science in a number of areas. Not enough people know it, but we are innovating so much that we are becoming more and more efficient.
Yes, there we go. There's the future-focused industry that we want to see. Bogdan.
Thanks, Sama, for the hint, and thanks, Philip, for mentioning the limits, because we have to be aware where our limits are, especially regarding the safe operation and safety margins. But knowing this, we can afford power upgrades, we can afford new technologies. Who knew about Internet of Tools a couple of years ago? Now it can save a lot of time. It can save workforce. Who knew about digital documents a couple of years ago? Now using digital work management, we were able to save tens of hours during each outage. So it's tens of millions a year per unit. So it's an amazing opportunity, not moving faster, not attacking safety margins, only to use the current opportunities of new technologies. So let's think about the possibilities, go out of box of former nuclear business and look around the current world. It works.
That's fantastic. So one area of where we've seen a lot of innovation, of course, has been in used fuel management. Really sort of world-leading investment in robotics and in extraordinary innovation in our used fuel management. Would one of our panel like to answer the question that we've had from our audience here about what we can learn from history and the way that we've handled it in the past, but really again looking into the future and the responsibilities that we have for continuing that extremely high quality management in future. Philippe.
Yeah, I'm not sure about the last part of the question regarding the responsibility for waste producers, but indeed, with new reactors and with a combined fleet, I mean, we can have and probably the way we can imagine it is having a fleet of really traditional reactors and a fleet of maybe reactors with more possibilities dealing with waste. And it's true that with some of the Gen 4 are fast neutron, and therefore you can really decrease the quantity of long-lived waste. Nuclear industry is quite young; it's only 50 years old. If we just think 30 years from now, 2050, climate target, but also nuclear waste target. In the meantime, we will continue to be in a position to innovate more and more, to recycle, with a target to have in this country 30% of the electricity, nuclear electricity, being done out of recycled materials. And in a position for, again, certain customers being able to recycle materials from others or their own materials. The technologies now fully allow this, and research reactors do allow this. And from all the customers I know, I don't know what was exactly meant with the responsibility, but I mean, our customers are dealing with their spent fuel and with their waste in a very cautious manner, and there is, of course, heavy licensing on nuclear either disposal or storage. With here again innovation for long-term storage of spent fuel, what we're doing in the US. Frankly, seeing accident on nuclear waste is so rare that I know only one.
I don't think there have been any. I think it's, this extraordinary track record.
There has been one
accident in spent fuel. It's not the waste we should be worried about, right? It's the it's the waste from it's the plastic waste in the ocean that we should be worried about. Sama.
No, I was just going to mention, this is something that I heard somebody mention when we were at the COP conference in Glasgow a couple of weeks ago. So, I mean, in reality, when I think about the history of the nuclear industry handling our waste, I would say that this is a very good story that we as an industry should be proud of. I mean, there is, I would say, no other industry that can say that they have managed every single kilogram of waste that was ever produced, that we know exactly where it is, that we are handling, that we have a plan for the long term, that the cost of doing that was actually included in the price of the electricity that we sold. So to me, that is a very good story. And actually, what I heard at COP, somebody mentioned, you know, if the coal industry would manage their waste the way the nuclear industry has, we would not need to have a COP. So that's all I would say.
Very good. Yes, it was. Well, I'd love to hear any other reflections on the perceptions from COP26 and how nuclear was represented. Sama and I we were both there, and yeah, we really found that nuclear energy was extraordinarily well represented. And one of the big themes that we heard over and over again from global leaders was the opportunity to repower coal plant sites with nuclear technologies. And this is really interesting because actually the prospect of closing down coal isn't just about shutting down a plant and stopping the emissions, it's the whole socioeconomic ecosystem around those plants that makes the prospect of closing them devastating for those communities, the loss of jobs and revenues and so on. And so there's a really interesting opportunity for nuclear energy to contribute towards addressing the largest single source of carbon emissions that we face. Oh, we do have another question. If anyone would like to comment on that, repowering coal, but we do have a question as well, so please feel free to answer that. How do we attract more young people, more talent, more diverse workforces? Maybe Patrick, you'd like to kick us off. Thank you.
So we have, I mean, as an industry, we have some demographic challenges. I mean, I guess we've seen in the past that we had a fairly experienced part of our population and workforce, and we have to manage the knowledge of that part of our teams. At the same time, we need to attract the new people that will be the future of our companies. The way we are trying to do that is first to make sure they can have diverse careers. It's also about mobility inside the companies, appetite to taste new technologies. We are a global company, and as a global company, we are present in 19 countries, and we also offer opportunities to discover other areas for the people who have the taste for it. And I would say we need to make sure, I mean, that's part also of the DNA of Westinghouse, that people can have a way to express themselves in different projects in their respective functions. We have education programs, challenges that take them into, from an engineering jobs into a service job and so on. So these are the type of things that can help to attract people into an industry which for years hasn't necessarily been painted as the most innovative and the most attractive. But again, I think the picture is changing. Changing with the winds, changing with the fact that nuclear energy is seen probably under a brighter light now.
Yeah, very good, thank you. Sama, did you want to comment on this one? You said you always wanted to be a nuclear engineer.
I always wanted to be a nuclear engineer, so I was an easy target for the nuclear industry. But no, I think it was last week, I was in Brussels in NEST ET 2021, which was the Nuclear Education and Training Conference. And one of the things that I heard from many of the experts that were there is, the very first thing that the young generation, Y, Z, etc., are interested when they are looking for a career, where they are looking for a work, for a job, is something they really want to contribute. They really want to feel that they are changing the world. They really want to know that what they do is important. And in that sense, I mean, I truly think that we have a very good story to tell, and that's what we heard at this conference. I mean, and you have seen many of, early career professionals and young professionals here, and they are here because they are passionate about how this industry can change the world.
Thank you. Bogdan, please.
Not forget that we cannot afford only to open the door and wait for them to come. So we have to enter universities, you have to explain, you have to be heard, and you have to be present among them during university studies, offer them the possibilities, show them what is possible. and as they like new technologies, new style of living, so let's think about how to allow them to use it at work, to make the work fun. And if they like the work and if they have fun at work, it's fantastic then.
Yeah, just one thing on top of all what was said. That's the people who are going to employ, but they are in an ecosystem of young people. And in this ecosystem, nuclear is not necessarily seen as positively as in older generation. And for this, communication needs to be addressed clearly through social networks. That's a huge difference with traditional communication that nuclear industry has done.
Petro, would you like to? Yeah, please.
In Ukraine, actually, we prepare the students for further work in nuclear power plants, and we have big staff at our nuclear power plants who are now nuclear workers and who works with us. This is about 35,000 people, and all of them are now have children, of course, and they are living near nuclear power plants. So we make a program just to support these children of existing nuclear workers at the plant, just to go to the university and to support them by the contracts with us, just to be educated and go back to our nuclear facilities just to work for us. And also we have contracts with universities in Ukraine, and there are actually 4 universities in Ukraine which prepare nuclear workers for nuclear industry. And all of them are contracted with us, and we are now thinking about establishing dual education. When they started education in the center, in the university, and then after the third year of study, they go to the nuclear power plant, and then they finish their education there. And when they get already graduated, then they're ready to work as nuclear engineers. Thank you.
Sorry about the announcement, everybody. Well, this may be our cue, so thank you so much for your attention, and please join me in thanking our very distinguished panel. Thank you.